Hello, everyone. Thanks for tuning in today. We are here to talk about space and space technology. We'll start in 1 or 2 minutes to allow everyone to log on and that sort of thing. As in the past, if you've joined before in the Facebook Live video, in the comment section, please type your questions. I'll try and answer a few as we go, and then we'll have time for some at the end to answer more. Hopefully you enjoy it. There's a lot of cool things happening in this area. And so we'll kind of highlight some of those, what's going on, some of the cool things I think that are happening. We won't get through everything because there's so many things that are happening, but just a good glance of what's out there. And we'll go from there. I hope everyone so far has had a good, it's Tuesday, right? Tuesday, there you go. Whatever day it is. You're having fun and enjoying it, and things are going well for you. Just if you haven't heard, there is the Eta Aquariid meteor shower going on this week. So the best nights are actually happening tonight and tomorrow night. So really early morning hours of Wednesday and Thursday morning. And so the best time to see the Eta Aquariid meteor shower is at 4 a.m. roughly local time, wherever you are. You want to look towards the northeast. So when you go outside, give your eyes 10, 20 minutes to adjust. It's really dark. Your eyes need to adjust, especially to see some of those fainter meteors that you may encounter. So take some time, allow your eyes to adjust. And then after that, you'll really start to see those meteors, those beautiful shooting stars. In most places, we can expect to see anywhere between 15 and 20 per hour, so pretty good rate. So every couple of minutes. And now meteor showers aren't just like clockwork, so you may have to wait for a few to see some, and then you may see quite a few in a go. So patience is always key with a good meteor shower. But it is visible from all across Australia, and in fact the entire southern hemisphere and parts of the northern hemisphere as well. Take advantage of that. So again, 4 a.m. local time, Wednesday and Thursday morning. The rate should be about the same, relatively the same amount of meteors per day. Wednesday's probably slightly better because the moon, which is almost full, will have set long before it. So we're about to get started in the video, in the Facebook Live. Type your questions and we'll get to it as we go. And we'll have time for questions at the end. So today, the real focus is on space and space technology. Really, where is space headed? What are we doing? What's happening? And what also with an emphasis, what is it Australia and New Zealand doing in this area? What are we contributing? What kind of cool projects are happening or on the horizon? So we're going to get into that. I think there's so many cool things happening. We won't be able to touch on all of them, but these are a few of my favorites. Now, I think it's always important to talk about, when we talk about Australia, we celebrated the moon landing, the 50th anniversary of the moon landing last year, and we'll touch on that in a little bit. But what the long history of space in Australia? So if I were to ask you what Stonehenge was, hopefully you know what Stonehenge is. It's that nice rock formation in the UK that tracks the motion of the sun. Well, have you heard of Wurdi Youang is Australia's Stonehenge. What you see here is this rock formation. So a bunch of astronomers and scientists have spent a lot of time mapping the positions of these rocks. They've dated them and the soil around it, and they've seen where they're laid out. And what they actually did was look at the layout of these rocks and tracked where the sun is moving relative to those rocks. And what you can see here, this area is about 60 by 80 meters, so it's actually a pretty big area. And you can see here that the rocks trace the sunset in the middle of summer, the middle of winter, and also in the middle, it's perfectly the equinox, which you can actually see here. So this tracks the motion of the sun and the relative motion of the Earth around it relative to our tilt, as we talked about a few weeks ago. So this is a space experiment. It's an astronomical experiment, and they've roughly dated it to about 11,000 years old. So Australia's Stonehenge is probably 11,000 years old, 5,000 years older than Stonehenge. I think this is kind of a remarkable thing when we think about space in Australia and what's happening is, let's not forget what has happened in the past, whether that past is yesterday, a year, 2 years, or 11,000 years, or 60,000 years. There's lots of great things happening. And I think that's kind of one of the exciting things in this field is we can see that history and we can see that contribution and what's been happening. Now, this video, is this video taken in space or not? I'll let you think about it a second. Is this video from space? Well, the answer is actually no, it is not taken in space. This is taken at 42 kilometers, and it's on a giant balloon. Now, I'll talk about that in a second. Now, the reason it's not in space is there is a very specific definition of where space begins. And that number is 100 kilometers. And the reason it's 100 kilometers is it's kind of just a nice round number. There's nothing physically special about 100 kilometers. 99 kilometers, 101 kilometers, it's kind of all the same. The reason we say 100 kilometers is there has to be that point where you can say the law of Earth ends and the law of space begins. And that's at 100-kilometer mark because there is space law. It's a big field. There's a few people doing it in Australia. It's a growing area. Because the reason being is we need to understand who controls and regulates space. So let's do a thought experiment, okay? So let's say there's a satellite company and they're based in Australia. So we have a private company in Australia who builds a satellite. Now they want to put that satellite into space. So they go over to our friends in New Zealand and they talk to Rocket Labs. So Rocket Labs is a private company based in New Zealand. So they say, hey, Rocket Labs, can you send this to us? And they say, of course. So this private company, Rocket Labs, based in New Zealand, is going to take this Australian satellite, okay? But they don't want to launch from Australia or New Zealand. Let's say they're going to launch from French Guiana. Now, the reason I've chosen French Guiana is Europe launches their satellites from French Guiana. All right, so we have an Australian company building a satellite that goes to a New Zealand rocket company, and they launch it from French Guiana. So that satellite goes into space. Now, let's say that satellite actually crashes into another satellite, call it Russia. So the Australian-built satellite on the New Zealand-built rocket launched from French Guiana, it's getting confusing here, crashes into a Russian satellite. Who's at fault? What does the law say about who's at fault? And the answer is French Guiana. Like literally the law of space is they who touched it last. And that kind of sounds comical, but when we think about it, the laws were written in the 60s and the 70s. And at that time, only countries built their own satellites and their own rockets and launched from their own countries. So in fact, the first country to build and launch a satellite was the USSR. Russia was Sputnik. The US was the second. And the third was actually Australia. Australia, with Rayasat, was the third country to build and launch a satellite. And they did it from South Australia. So we could see the law has changed in the sense that we have private companies. We have countries that cooperate quite closely. And we share things. And there's actually kind of becoming an issue. The law is not keeping up necessarily with the technology in space. The things that we're able to do have kind of really passed what the laws were written for. Treaties aren't meant to be updated all the time. And so there's a big push in Australia and other countries to say, what is the best way to govern moving in space? And how do we cooperate? Because we don't want to hinder and prevent new things from happening and cool, exciting things. But at the same time, we want to make sure people are responsible. So a good example is this. Russia launched a satellite. So if you know those Russian babushka dolls, so Russia launched a satellite and the satellite went into space. Well, a smaller satellite popped out of that one and a smaller satellite popped out of that one. The balloon just popped, I'll explain in a second. So, all right, so we have a satellite that's going up, a second satellite popped out of that one and another satellite popped out of that one. Why is that important? Well, the second and third satellites how do we exactly prove who launched it and who's responsible? What happens if it does something or is doing something? So the technology is really cool, but we have to make sure that the law is representative of that technology. And so there's a lot of great people working on this area about this whole area called space law. Now, this video, as I said, is taken from this balloon. So one of the cool things we get to do is build giant telescopes and put them on the bottom of balloons. And the reason we do this is this video was actually taken from just a little weather balloon that went up and popped and everything came down. We collected it. But you can see here, we're almost like in space. We're above the ozone. And the reason we're above the ozone is the ozone sits between about 20 and 40 kilometers. Now, the ozone luckily protects us from getting burnt from the sun. But the cool thing is that it also blocks ultraviolet light when it does this. Now, in space, we like ultraviolet light because it tells us about hot things, young things, things that explode. So we can build a balloon and it can go above the ozone and we can see like we're in space, and then it can come back down and land and we can relaunch it. So we're building telescopes right now. We're designing them to go to the bottoms of telescopes, to balloons, to float around and see like we're in space and kind of almost be reusable. So it's a really cool thing we're able to do now that isn't just necessarily building a satellite. And these actually have been around for decades. Lots of groups put things on balloons. One of the cool things is at 40 kilometers, the environment is very similar to Mars. So if you want to test things like it's going to be on Mars, you can see how it is inside the Earth's atmosphere. And in fact, you can actually see this was one of the groups we work with. You can see the little balloon icons when you go to flight radar sometimes. This is from last year. But this is kind of the idea is we can put these balloons in the air. They're above airplane traffic. They don't interfere, but yet they're not so far like satellites that we can't get them back. Now, there's a lot of talk about going back to the moon. This is, I think, one of the coolest projects happening with that. It's called the Gateway. And this is essentially a moon space station. So if you imagine we have the space station going around the Earth, it goes around the Earth every 90, 92 minutes. This space station will be our space moon lab. So the idea is we can build a space station, and parts of it are already being built and designed right now. They hope to potentially launch some parts by as early as 2022. So only in a few years. It's kind of really exciting. So the idea is if you launch a space station, it can orbit the moon, it can house up to 4 people for a couple of months. They can do their experiments, they can do their science, and they can come back down. Now, there's lots of groups who are participating in this, and Australia is. Now, and again, if you have questions about this or other things, feel free to type it in the Facebook Live window in the chat box, and we'll try and answer them as we go and at the end. Now, the reason we're thinking about this is we want to go back to the moon. So yes, we did land on the moon 50 years ago and a few times since then. I really like this photo taken from Apollo 11 for a few reasons. There's some really cool things in here. Firstly, it's this thing in the middle. So this thing is what we call a metal reflector plate. So it's a giant plate, which isn't terribly big. It's maybe the size of a small table. Here, you can kind of see. And Apollos 11, 14, and 15, plus lots of other missions, the Russian missions, and even modern day robotic landing to the moon, we've put these on the lunar surface. And the reason these were put on the lunar surface was to actually measure exactly the distance to the moon. So by putting this little plate down, a giant laser was shot at it. In fact, the Auroral Tracking Station here outside Canberra is one of the groups that started to do this back in the 60s, and lots of groups all around the world in the US have done this. We fire this laser at this little plate, and then it bounces back to Earth. So by knowing the speed of light, we can precisely measure the distance to the moon by the time it takes that laser to get there and back. And we know the distance to the moon within about a millimeter, literally 1 millimeter distance accuracy to the moon. It's amazing we've been able to do this. And this has taught us all sorts of things about the history of the moon, how we think it came from a collision with the Earth, as we talked about it a couple of weeks ago, how it's formed, and that it's drifting away. All of these things we know because these little plates were left around the lunar surface to know exactly how far it is. Now, the other thing I like here is this little thing here, this little pole. Any idea what it may be? Well, it's not a temperature gauge. It's a seismometer. It measures moonquakes. The moon has moonquakes. They don't have earthquakes because it's not the Earth. It has moonquakes. I think that's kind of cool. The moon has moonquakes. And what we know about these moonquakes is that it's because this tug of war, this battle of gravity is being played out between the Earth and the moon. As the moon tugs on us, we get our tides and things like that. As we tug on it, we're actually kind of causing the surface to crumble a little bit, causing it to almost collapse in on itself. And these are what we call moonquakes. Now, the other important part is the lander here. And one of the funny things I think that happened with the Apollo 11 landing is that when the lander happened, so if you've ever seen the video of the Apollo 11 moon landing, they landed it, Neil Armstrong landed it too well. So we actually thought, the scientists who were designing it thought that the legs would actually sink a bit into the surface. Why these legs are actually built as large as they were. But Neil Armstrong landed it pretty well. And if you've ever watched those videos, you know, they hop, hop, hop down. They weren't fully supposed to hop all the way down to the ground. Now, one of the problems is fluids, let's say, move differently in space. And when you have to go, you have to go. And so the astronauts have bags to collect their pee, and the bag was in their boot. Well, Neil Armstrong comes down, he's all fine. Buzz Aldrin hops, hops, hops. And he hops onto the moon. Well, the bag broke, and his boot started to fill with pee. Now, obviously, he's on television. He doesn't want to say, hey, got this problem here. So he just walked around with it and then dealt with it when he got back into the capsule. It's kind of amazing to think of these kind of important everyday things that happen. And it doesn't always go perfectly planned according to space. And that happens as well in the moon. Someone's actually asked before, who else is helping with this return to the moon mission? Lots of countries. So it's spearheaded by the US. Australia is participating in this mission. The European Space Agency as well, and also private companies. Now, the reason these groups are coming together, and I'll explain in a second, is because of this. And that is, we can land on the moon and actually get something. We can get ice. There is a lot of ice on the moon, mostly discovered firstly by the Chandrayaan-1 mission, the first Indian mission to the moon. There's lots of ice on the moon. That means ice is usable for drinking, obviously H2O, but also it can be used for rocket fuel. You can actually use the hydrogen and the oxygen to refine it to make rocket fuel. So if you can land on the moon, you don't have to carry the fuel with you. You can land on it, get the fuel, and come back. Or you can land there and get to somewhere else. Because this is kind of a cool thing. So when we think about the Earth, we have gravity. That's why I'm sitting down right now. That's why you are where you are. We also have this atmosphere, helps us breathe. But it makes rockets hard. We have gravity, it holds it down. So if we add more fuel, we add more weight. So we add more fuel, we add more weight. So it makes this kind of battle of how quickly we can take off of. But the moon has very little gravity and very little atmosphere. That means it's easier to launch on the moon than it is the Earth. So if we can get to the moon, we can refuel and launch to other places in space or come back to Earth. That's kind of the whole goal. That's the name of the game. And so this whole idea of how we get hydrogen and make it into rocket fuel. In fact, Caitlin, one of our students here, will be talking about this on the Mount Trumbull Facebook page on the 14th, and actually do a little demo about how you can make your own hydrogen at home with supervision, kids, please. But how we're using this in our modern rockets. So that's why there's this renewed interest in the moon. And in fact, just the other day, NASA, as part of their plan of return to the moon, what we call the Artemis mission. So the Apollo missions took us to the moon back in the 60s and 70s. Artemis is the new name of the mission, Artemis being actually the goddess of the moon in Greek mythology, Apollo's sister. The lander is going to be built by private companies. They have 3 companies are vying to design it. Blue Origin, which is Jeff Bezos' company, Elon Musk's SpaceX, and the third company are all designing the lander for it. So this return to the moon is not just NASA. It's a bunch of countries and private companies. And in fact, uh, the private companies themselves have their own visions of this. SpaceX wants to land on the moon, again, for the same reason. If they can stop off on the moon, they can get further places into space. And you can see an animation here of what they call their spaceship, their Starhopper rocket, which they're hoping that will land on the moon. They can refuel, take off, and come back to Earth. And these things, these aren't far-fetched. These are not things that are 10, 20 years away. It's happening in the next few years. People are working on them right now, and Australia is playing a big part. There's companies in the Gold Coast in Australia, in fact, Gilmore Technologies, working on some of this rocket technology as well. So lots of these things are happening really quickly, and I think just really exciting. And it's not just the US. All the way up until the beginning of last year, January 2019, only 2 countries have ever landed on the moon, the US and Russia. In 2019 alone, 3 other countries tried. China did on the beginning of January. Talk about it in a second. Israel tried in April, but they had what we call the hard landing, which is kind of a fancy term for crash. But they got pretty close. And it was built by a private company as well. And in India, partially did it as well in September. They had an orbiter, a lander, and a rover. The lander landed on the moon. The orbiter is up there. They had a problem with the lander. It didn't land as perfectly as they intended. And so the rover wasn't able to get out. So mostly successful. But none of the Apollo missions were successful in the beginning. Neither were the Russian missions. And so it's hard. The important thing here is we have to look at why Apollo stopped. In fact, Jeff Bonning will be talking about this next month on the Mount Trumbull Facebook page about the history of the Apollo program. The Apollo program was expensive. It cost about $150 billion, billion with the B, which is a lot of money. As my son would say, that's a lot of Lego. That was not sustainable. So what happened was it stopped. But the cost of technology has changed. So to put this in a scale, the India mission cost just around $100 million. Now that's still a lot of money, but let's put this into scale. If you saw the Avengers Endgame, that cost $242 million. You can make 2.5 missions to the moon for one Avengers Endgame. In fact, the movie Gravity was $120 million. It is now cheaper to go to the moon than it is to make a movie about going to space or the moon. I think it's just utterly amazing how much it's changed. And not only is the cost cheaper now, but we can use it as a way to get further into space. So that's why there's this focus on the moon. And for good reason, because there's a lot of things we're now learning. And as I said, China landed on the far side of the moon back in January last year. And if we remember a talk from a couple of weeks ago, there is no dark side of the moon. There's just a side we can't see, the far side. In fact, this is the dark side of the moon, but in sunlight. And this lander had a very important experiment, I think. And what they had was a little bubble. And in this bubble, they had potato seeds, cotton seeds, and silkworms. So they had a little greenhouse. So as the silkworms breathe, they breathe out carbon dioxide. That helps the plants grow. The plants breathe out oxygen, which is what animals breathe in. They created a little living environment. They grew seeds. They grew plants on the far side of the moon. Something I don't think anyone really ever thought we would be doing anytime soon. But the Chinese did it when they landed their mission, Chang'e back in January. So lots of exciting things are happening because ultimately the goal is if we can land on the moon and we can use it, we can go further into space like Mars. Now, I don't think we're going to get to Mars anytime soon, at least humans. It's pretty easy relatively, to send robots and rovers. It's pretty hard to send humans. So, SpaceX wants to colonize the moon. There's a lot of issues with that. It's not straightforward. Let's put this into scale. People are planning to take about 3 to 4 days to get to the moon. So, kind of a 7-8 day trip there and back, plus whatever time you spend on the moon. Relatively quick. To get to Mars, the quickest we can really make a trip to Mars is about 6 months. So 6 months to get there. And then when you land there, you're on Mars. It is so far away that it takes 20 to 25 minutes to send a message back to Earth. So imagine you're on Mars and you say, hello, hello, hello. How are you going? I could really use some help. You have to wait for about an hour to get a reply. You can't do anything about it. To put this in the scale, the moon. So remember we talked about that laser beam going to the moon and back. It takes about 3 seconds for the laser to get to the moon and back. So it's about 1.5 seconds roughly each way. 6 or 20 minutes sometimes for one-way communication to Mars. And when you get there, it's not like we can help you. So if you're an astronaut in the space station, there's actually an emergency capsule. There's a Soyuz capsule that if something goes wrong, you can evacuate and come back down to Earth. You can't do that on Mars. And, imagine this. You're going to Mars. The capsule you're in isn't very big. The big version is maybe the size of a small room. The small version's about the size of a car. And you could be sharing this with anywhere between 2 and 6 people. They're not going to be these big, luxurious, where you have your own bedroom and your own, you're kind of cooped up. You're kind of stuck in a fairly small area for a very long time. You can't go outside and you're stuck with other people. So there's a lot of issues in the getting humans to Mars. And how they're going to survive and mentally survive. We've all been in isolation here for a couple of weeks. Imagine if this is going to go on for months and months and months and months. And then if you get to Mars, there's a trick. And if you remember, we were talking about the solar system, the closest planet to Earth is Mercury because it goes around the moon every 88 days on average. The closest planet a planet ever gets to Earth is Venus. But the problem is, right, they're like 2 cars going around a racetrack. Sometimes we're further away. And this happens with Mars. Sometimes we're over 200 million kilometers away. So you have to wait for Earth and Mars to get back on the same side of the sun. So you're going to be spending a long time on Mars, and then you can come back. 6 months taking back. Really, the quickest you can make a trip to Mars and back is about 3 years, just shy of 3 years. That's an awful lot of time. How we're going to manage that, how humans are going to manage that is a big deal. Now, if you get to Mars, and again, remember, if you have any questions about Moon or Mars or anything else we're talking about, feel free to post it. Mars is pretty dry. There's very little water on the surface. The atmosphere is mostly carbon dioxide. So you can't just walk around and breathe it. If you are outside for 5 minutes, you're going to pass out and then you'll probably die. So you have to live in bubbles or habitats or environments. Some people think we may have to live underneath the ground. Then where are your supplies coming from? Either we have to land it there or we have to dig and find them on Mars. Now, Mars, luckily, we know, has these big oceans underneath the ground. So about 1.5 kilometers deep, there's giant oceans. It's salt water, but you can fix that. You can desalinize it. We do this here on Earth. And you can, again, use that water, just like on the moon, for rocket fuel, for drinking, for breathing, and that sort of thing. And here becomes the issue. If we don't find ways of using the things in space, it's going to be really costly and hard. So to put this in a scale, it costs anywhere between $2,000 and $20,000 per kilogram to put something around the Earth. So let's say you need 8 liters of water a day. That's 8 kilograms. That's $160,000 as your water bill. If you're up there for 100 days, $16 million in water alone per person. And it's much more expensive to get to Mars and the moon. So this is the problem. We need to find ways of not just reliant on sending things into space for a number of reasons, but we need to find things in it. Someone's just asked, what about the sun getting bigger and bigger? The Martian atmosphere is a bit weird. It's less dense. So the pressure is about a third the Earth's pressure, which means that the temperature is different. So there can be upwards of 20-degree difference between your feet and your head. So your feet can be 20 degrees Celsius and your head is 0 degrees Celsius. So as the sun gets bigger and bigger, it eventually will change the Martian landscape, but probably not on the time scale of a human. It's going to take billions of years as the sun gets bigger to really change any of the temperatures or environment of the planets in our solar system. So it's not something that we can really rely on. So we're going to have to solve this problem ourselves. We have to find ways of obviously getting our atmosphere and our air. So it's not as straightforward as just saying, hey, people, go to Mars. If we really want to put someone to Mars, they could probably do that soon. They're just not going to really survive, or at least be healthy on the trip to Mars. So there's a lot of work that we can be done, and a lot of work, and as I said, in that area of finding things, extracting things in space. And now this is something that Australia is working on. So the Hayabusa 2 mission was a mission built by the Japanese Space Agency that Australia participated. This landed on an asteroid last year, the asteroid Ryugu. Now, asteroids are essentially frozen chunks of metal, lots of ice, lots of metals on it. And what Hayabusa 2 did is 3 times it landed to the surface, and it had this giant vacuum cleaner thing. It went down to the surface, and it went, sucked it all up. And you'll see here that we're going to get to the surface in a few seconds. We did this 3 times, and in between the second and third time, there's a little capsule that contained 10 kilograms of C4, and we blew a hole in the asteroid. So you'll see here, we'll touch down in about 3 seconds. 3, 2, 1, touchdown. There's all the rock. There's a bit of the hole in the shadow. So this probe landed, it extracted as much thing as it could. And we did this multiple times. Now this whole thing has been sealed. It's on its way back, and it's going to land in South Australia in December. So we can land on things and start to extract things. There's an OSIRIS-REx mission led by NASA that will have this giant arm that goes down to the surface of the asteroid Bennu and does a bunch of these similar things as well. So this is something being worked on. How do we extract things in space? It's also another legal issue. The current law says that anything in space is no one person can own it. It's a property of everyone. Now, everyone wrote into the rules and the laws that, scientific exploration and understanding it's a bit different. So, we want to study these. We're not really owning them. We're just going to study them in a lab. But what happens if people start to mine it? What happens if people start to dig things out? This becomes a bit of a trick here. And it's a big legal area people are working on. How do we allow this to happen? But how do we control the rules and make sure it's fair for everyone? Because this is something happening, and it's going to happen more and more. And the reason we care about this, as I said, is we want to send Matt Damon to Mars. And it's not just straightforward of sending Matt Damon to Mars. There's a number of reasons why. There's health problems, right? As we talked about. There's radiation. Now, on Earth, we have this giant protective magnetic bubble, and this keeps us safe from most of the radiation from the sun. That's not the case on Mars. We know that Mars is, the inside of Mars has weakened. It's allowed the magnetic bubble to weaken. So there's a lot more radiation on Mars. There's a lot of radiation getting to Mars. That's not very safe. There's lots of health problems that astronauts have in space. And this is the big thing people are trying to get a deal with. How do we make them safe and healthy and prevent them from getting sick in space? And some of that is psychologically. People are looking at different ways of how do you cope with being held indoors. In fact, in the European Space Agency, they lock them in caves to try and see how they can work as a team. Because it's not just about you, it's about your friends, because those are the only people you can rely on Mars. There's a lot of these issues with getting to Mars. And Australia is doing a lot of these different things, from how do we extract this in space to how do we get them safely there? Because let's put this in a scale. We've talked about the solar system, but what about other places? So let's think of Voyager. Let's put this in the context of Voyager. Voyager is the furthest probe we sent into space. Now, let's say we want to get to Alpha Centauri. Alpha Centauri, if we look in the nighttime sky, here's the Southern Cross. Here's Alpha Centauri. It's what we call the pointers. It's one of the bright stars that point to the Southern Cross. This is the nearest star to us. It's 4.2 light years away. If Voyager was aimed at Alpha Centauri, it would take 75,000 years to get there. 75,000 years to get to the next closest star system. There's no way, there's no other place. That's it. If we want to get to somewhere, say, the center of our galaxy, like Sagittarius A, if you saw the video last week, this is kind of looking towards the center of our galaxy, and you can see all the stars moving around. and you can see that there's something orbiting it. Oh, and stay tuned. Wednesday night, Australia time, 10 p.m. or Thursday morning, there'll be a cool announcement about black holes as well. Black holes are the happening thing. So let's say you wanted to get to the center of our galaxy, Sagittarius A star. It would take Voyager 450 million years to get there. That's the center of our own galaxy. So imagine this, the dinosaurs disappeared about 65 million years ago. We are much closer to living with the dinosaurs than getting to the center of our own galaxy. So what can we do about it? We can try and build better ways of traveling in space. And Caitlin will touch on some of these as well next week on the 14th. And this is a kind of a cool video. So this is what we call a plasma thruster being developed here in Canberra, led by Christine Charles at ANU. So we have a little ball of plasma, and you see it's going to get bigger, bigger, and bigger. It's going to stop in a second. At Mount Stromlo, we have a giant chamber that simulates the conditions of space. Now, this little thing doesn't look like much. I'll just play it again. I'm going to leave my mouse here so you can see how big it gets. And it grows, and it grows, and it grows. And plasma is, we have solids and liquids and gases. Plasma is what we call the fourth state of matter. We take a gas, and we superheat it. And this changes the properties of the gas. It makes it really powerful and energetic. The reason this is exciting is this only weighs a couple of grams, not kilograms, not tons, grams. And in fact, this technology is now used to power a lot of satellites to actually make them operate in space. So this gives a whole kind of new way of maybe there's a better way of traveling more efficiently in space. There's even groups looking into things like the breakthrough starshot. If we attach a sail to a satellite, now, we talked about gravity in the atmosphere holds us down. Well, what if we put a satellite in space? We put a giant sail onto it. And let's shoot a laser, shoot a big, powerful laser at this sail. We can make it go 20 or 30 or 40 or 50% the speed of light. Well, it's outside the Earth, so no atmosphere or gravity to slow it down. So it's just going to continue going at 20 or 30 or 50% the speed of light. So instead of taking 75,000 years to get to Alpha Centauri, it can only take decades. So there's a really cool promise of potentially finding faster ways to travel into space, but that's still decades. Humans are only going to really be able to explore the solar system anytime soon. So there's a lot of work to be done to actually make that happen. And there's a subtle problem to this as well. So this is an image of our galaxy. It's 100,000 light years across. So let's imagine it this way. If I put a torch over here and I turn it on, it's going to take 100,000 years for the light to get all the way across over here. We can't solve that. If you look here, you see this little blue dot? Let me zoom in here. So it's about 200 light years. That's not Earth. That's how far our radio signals have gone into space. We've been broadcasting radio stations. They have not gone very far into space. So if you're over here, you haven't heard from us. So let's go back to Alpha Centauri. It's 4.2 light years away. So imagine I put you there right now and you say hello. I won't hear the hello for 4.2 years. And then I have to reply back. So it's 8.5 years to get a reply. So, we complain about the NBN in Australia. This is even slower than that. There's no way of getting around that. We can't solve that problem. So even if we have a way of sending something to the nearest star to us, it would still take a long time to communicate with it. So even though we think that there's all these places in space and all these galaxies, there's trillions of galaxies here, every little square or dot or image in here, minus a few, is an entire galaxy with billions of stars and planets around those stars. We can't go there. We cannot even communicate with there. It's just too far. So we have to find other ways of exploring space in our own solar system. But there is another problem that we have. As we do this, we're putting a lot of satellites around the Earth. There's about 5,000 satellites rather, more than 5,000 satellites around the Earth. This is kind of an image of the satellites around it. It's not to scale, but there's a lot in there. And the problem is these satellites can be very small. That's actually really good because they're lightweight. In fact, this is a satellite built in Canberra. It's about the size of a loaf of bread. So you can really build satellites the size of loaves of bread now and get them up into space because it's quicker to build, lighter, and therefore cheaper. But the problem is, as we get more things, things can crash into each other. So in fact, in 2009, this satellite, this Russian satellite, crashed into this US satellite phone company, and it produced 10,000 pieces of debris. And the reason we worry about this is this on the left. So this is taken from the space shuttle Atlantis. Now the space shuttle, its windows were essentially bulletproof glass. And this hole is 5 centimeters deep in bulletproof glass. And it was caused by a flake of paint. Literally a piece of paint created a hole 5 centimeters deep in bulletproof glass. If you're traveling 40,000 kilometers an hour, you don't have to be very big to do a lot of damage. And think of the bigger things. Like there's literally a screwdriver and spanner orbiting the Earth at 40,000 kilometers an hour. You do not want to get hit by it. So something done in Canberra. So this is led by a private company called Electro-Optic Systems, and there's a special research group, the Space Environment Research Center, based here at Mount Stromlo. And what we're doing is building a laser system to not only track debris, so we can find objects centimeters wide, thousands of kilometers above the Earth. And now a laser is being built to actually deorbit it, to clean it up. So we can actually think we can use lasers to clean up space now. So even though we might be creating more problems, we're also finding ways of solving those problems as we do it. So imagine we're building lasers to get rid of things in space safely and to help space travel be a lot more safe. So there's lots of cool things happening. And I know this is not everything, and this is just a glance. We can spend hours talking about this. But I think the cool thing that's happening is things are happening so fast in space and such a cool way that a lot of things are going to happen. Now, I know there's been quite a few questions. I'll try and answer a few. So someone's asked, will moon bases be good for missions to Mars? Yes, that is the goal. If you can land on the moon, not only is it easier to get back to Earth, but it's easier to get to Mars. It's cheaper and quicker. It's still going to take a very long time, but it makes it a bit more efficient getting to Mars and other places in the solar system as well. Someone asked, could there be life floating in the atmosphere of the gas giants? This is a tricky one. Probably not the way we think life is and not the way we're looking for life. Really, the best spots to look for life are some of the moons of Jupiter and Saturn, Europa and Titan. They have lots of water and thick atmospheres that we think can support life. And so there's a lot of missions being planned to look there. Do you think that there could be a type of life that we haven't discovered living on Mercury? So when we look for aliens, we look for things like Earth. And that's because the only place we know of is here. Doesn't mean that's right, but we have to start somewhere. So we look for places like Earth or that have water or there's environments. Now, a big area that we use is something called extremophiles. So we look for the extreme places on Earth that could host life. And we look for those to see in the craziest, most harsh conditions of space on Earth, if we find those in space, is there life there? So we've looked at the bottoms of underwater volcanoes, Lake Vostok, which is this ocean or lake underneath Antarctica that's been buried. It's kilometers deep and buried for 2 million years. It's never had sunlight. And all these places we look, we find life. So places like Mercury and Venus, it could be possible. Mercury, probably less because of the atmosphere, but Venus, even though the atmosphere of Venus is very toxic and it's hard and hot to us humans, at our type of life, there could be something that survive it. So we'll take about 2 more questions. And if you have any more questions afterward, feel free to type it in. Do I want to go to Mars? Not at all. The reason I don't want to go to Mars is it's tricky. It's not safe. That doesn't mean it won't be. It doesn't mean problems won't be solved and it won't be safer. But it's going to be a lot of work. And I'm happy here on Earth. I'm happy other people want to go into space. You know, the Apollo missions were risky as well. There was a lot of risk in the Apollo missions, and there's still risk even today. My reasoning for not wanting to go to Mars also is, you know, we don't see a lot of people flocking to move to Antarctica or the Central Australian desert. Those are much easier to live than on Mars. So, you know, there will always be people that want to explore, and that's great. and we need those people. That's just not me. I'll use my telescope here on Earth. And now this is a very good question, and I want to end on this. And again, I'll try and answer other questions in the Facebook chat afterwards in the video. If other questions, feel free to post it. What kind of technologies have spun off from space? I think it's a very good question. Space is costly, but one of the exciting things is that we ask these really big questions, these really hard problems, so we get very creative solutions. The laser system's a great example. We use the same laser system to perfect measurements to GPS satellites and refine the positions of GPS satellites and get the accuracy down. And if we didn't, so GPS satellites are moving so fast, they're in a different frame of time. And if we didn't correct for how they drift and their time drifts, our GPS maps would be not accurate at all. But using this technology and some of the other ones, Geoscience Australia is leading a project to actually get the accuracy of GPS maps down to centimeters, 5 to 10 centimeters. So imagine being able to know your position to within 5 to 10 centimeters. This is amazing, not just for us moving around, but farming, tracking weather, disaster relief. If you can know exactly where things need to go and what is happening, we can better support it. The Apollo programs, there's been so many spin-offs from air conditioning and oxygen systems to computer systems. A great thing of the Hubble Space Telescope, when the Hubble Space Telescope was launched, we just had its 30th anniversary the other week. The mirror was installed wrong. It was polished a bit too well and installed at a slight angle. So it's kind of like your glasses being a bit out of focus. They eventually fixed it, but some software was written to correct the images. That software was used in mammograms to detect tumors. So there's all these little things where these creative solutions have pretty big spin-offs. Solar panels, it's a pretty big thing. Solar technology is direct related to space. We needed to develop it to power satellites and probes and spacecraft. We use that kind of all the time now. All these times where we work, because the harsh conditions of space means a lot of the things that we can't use here on Earth, we need to develop something different, and then we find ways of doing it and spinning it back down. So that's, I think, always the great thing about space and the technology is we push ourselves, and so we push our answers, and we get really cool things. So I hope you've enjoyed today. Again, if you have any other questions or if I haven't answered them, I'll try and come back and answer them in a little bit. Stay tuned. Lots of these things are changing every time. There's more and more things happening. And as the people and countries and groups return to the moon, there'll be even more exciting things. So thanks for watching and stay tuned. And this recording will be on the website, the map show on the website and Facebook as well. So take care.